Hi everyone. Today we're going to study reflexive and symmetric relations. Let's begin with reflexive. A relation R on a set A is called reflexive if the ordered pair AA is an element of R. For every element A is an element of set A. Example 1. Given the following relations on the set 1, 2, 3, 4, which of them are reflexive? We have here 6 relations. Relation 1, the ordered pair starts with 1, 1 up to 4, 4 respectively. Relation 2, from 1, 1 up to 2, 1. Relation 3, from 1, 1 up to 4, 4. Relation 4, relation 5, from 1, 1 up to 4, 4. Relation 6 has one ordered pair, 3, 4. For our solution, we say that the relations R3 and R5 are reflexive, as they contain all the pairs of the form AA, namely 1, 1, 2, 2, 3, 3, and 4, 4. The remaining relations are not reflexive. This is the final answer. Example 2 is the divides relation or divisible by on the set of positive integers reflexive. The divisible by relation can be defined as follows. The relation R equals the ordered pair AB such that A divides B, where A and B are elements of Z with power plus. This is the symbol for positive integers. We say that the divisible by relation is reflexive because A is divisible by A whenever A is a positive integer. This is the final answer. There is a note. If we replace the set of positive integer with a set of integers, then the divisible by relation is not reflexive because 0 is not divisible by 0. Let's proceed now with symmetric. A relation R on a set A is called symmetric if and only if the ordered pair AB is an element of R. Implies that the ordered pair BA is an element of R. For every AB is an element of set A. In other words, if R is symmetric, then A is related to B implies that B is related to A. Example 1. Which of the following relations are symmetric? These are the same relations that we have a while ago. So we say that relation 1 is not symmetric because this 3, 4 is an element of R1, but 4, 3 is not an element of R1. Also, this 4, 1 is an element of R1, but 1, 4 is not an element of R1. Again, we say that R1 is not symmetric. Next is R2 and R3 are symmetric. Looking at our R2 here, there is an ordered pair 1, 2, and there is an ordered pair 2, 1. For the R3, we have here 1, 2. Likewise, we have 2, 1. There is an ordered pair 1, 4, and also 4, 1 is present. So we say that R2 and R3 are symmetric. R4, R5, and R6 are not symmetric. Let's begin with R4. We have here one ordered pair 3, 1, but there is no ordered pair of 1, 3. That makes R4 not symmetric. In R5, we have here one ordered pair 1, 2, but we can see that there is no ordered pair for 2, 1, and that makes R5 not symmetric. For the R6, there is only one ordered pair, 3, 4. Obviously, there is no other ordered pair which is 4, 3. Again, we say that R4, R5, and R6 are not symmetric. Example 2. Which of the relations below are symmetric? Relation 1. The ordered pair AB such that A is less than or equal to B. Relation 2 is the ordered pair AB such that A is greater than B. Relation 3 is the ordered pair AB such that A equals B or A equals negative B. Relation 4 is the ordered pair AB such that A equals B. Relation 5 is the ordered pair AB such that A equals B plus 1. Relation 6 equals the ordered pair AB such that A plus B is less than or equal to 3. First, relation 1 is not symmetric because one example is here. 3 is related to 5, but 5 is not related to 3. Next, relation 2 is not symmetric because when A is related to B, B is not related to A. Relation 3 is symmetric because if A equals B, then B equals A. Also, if A equals negative B, then B equals negative A. Relation 4 is symmetric because if A equals B, then B equals A. Relation 5 is not symmetric because when A equals B plus 1, B is not equal to A plus 1. Relation 6 is symmetric because if A plus B is less than or equal to 3, then B plus A is less than or equal to 3. We're going to study two properties of relations, and these are anti-symmetric and transitive. Let's begin with anti-symmetric. A relation R on a set A is called anti-symmetric if and only if the ordered pair AB is an element of R and the ordered pair BA is an element of R, implies that A equals B for every A and B as an elements of set A. In other words, if R is anti-symmetric, then A is related to B and B is related to A, implies that A equals B. Example 1, relation 1 equals the ordered pair AB such that A is less than or equal to B, for A and B are integers. Is an anti-symmetric relation because A is related to B and B is related to A. It implies that A is less than or equal to B and B is less than or equal to A. It follows that A equals B. Example 2, A is related to B if A divides B on the set of non-zero integers is an anti-symmetric relation. Let's go now to transitive relation. A relation R on a set A is called transitive if, whenever AB is an element of R and the ordered pair BC is an element of R, then the ordered pair AC is an element of R for every A, B, and C, and elements of set A. That is, for a transitive relation, if A is related to B and B is related to C, then A is related to C. Example 1. The relation R equals, here are the ordered pairs 1, 1, 1, 2, 2, 1, and 2, 2, is transitive. Let us examine this relation. We begin with this first ordered pair. 1 is related to 1, and this one is connected to 1, 2, and we say that 1 is related to 2. So it implies that this one must be related to 2, and we write here 1 R2. This 1 R2 denotes this ordered pair 1, 2. Next is the ordered pair 1, 2, and we write here 1 is related to 2. Then this 2 now is connected to this ordered pair and this ordered pair. We start with a 2, 1 here, so we write 2 R1. It implies that this 1 must be connected to 1 here, so 1 R1. We can see that there is an ordered pair that is 1, 1, and it is satisfied. Then we go to this 1, 2 in connection with this 2, 2. It follows that 1 R2, and this 1 R2 is this ordered pair 1, 2 here. Next is this ordered pair 2, 1, and we write here 2 R1. This one will be connected to this ordered pair and this ordered pair. Let us now connect first with the 1, 1. So we see here 2 R1 and 1 R1. It follows that 2 must be connected to 1, and we write 2 R1, and we have this ordered pair for this. Next is this 2, 1 in connection with this 1, 2. So 2 R1 and 1 R2. It implies that these 2 must be connected to 2. So 2 are 2. And we have this ordered pair for this. Next is this 2, 2 in connection with this 2, 1. So we write 2 are 2 and 2 are 1. It implies that these 2 must be connected to 1. And we write here 2 are 1. And these 2 are 1 as a corresponding ordered pair in here. And that is A is related to B and B is related to C. It implies that A is related to C. Therefore, this relation R is transitive. This is the final answer. Example 2. The relation R equals the ordered pair AB such that A is less than B, where these AB are elements of set A. And we say that this relation is transitive. Let A related to B and B related to C. It follows that A is less than B and B is less than C. It implies that A is less than C. By this inequality here, we can write A is related to C. This is the final answer.